Today we're doing the ellipse. As you can see, there are many examples of where you can see an ellipse in real life, and we're just going to take a look at the parts of the ellipse today and how to get these parts from an equation or from a graph. Here are some key words that you might want to jot down because we're going to use these keywords when describing an ellipse. Two foci, which is a fancy way of saying two focuses. Focuses is not good English. One focus, two foci. So whereas you are used to in parabolas having one focus, you're going to have two foci in an ellipse. We're going to have what's known as a major axis, which is just the longer part of the ellipse, because you know the ellipse is not a perfect circle that has a radius. It's kind of like an oval, so the long distance on the oval is the major axis, and the short distance on the oval is going to be the minor axis. Vertices, much like foci, is a plural of vertex. So we're not going to say vertexes, it's two vertices. And the vertices are the ends of the long part of the ellipse. And then we have two covertices. Covertices are the short ends of the ellipse. Here we have two ellipses. One of them is horizontal and one of them is vertical. Now the only difference between horizontal and vertical is which way the major axis is turned. The major axis is simply the longer side of the ellipse. So if you look at ellipse A, you'll see that the longer side is horizontal, and therefore the major axis is horizontal, and therefore the ellipse is horizontal. So this is a horizontal ellipse. As you can see in the second ellipse, the longer side is vertical, so this would be known as a vertical ellipse. Now the way that the major axis is turned kind of determines a lot about the ellipse. Let's take a focus on the horizontal ellipse. As you can see, the distance from the center to the vertex is a units, and we're going to determine a from the equation. Now in the equation, what you're going to have is you're going to have x minus h squared divided by a number plus y minus k squared divided by a number. These numbers represent a and b, the ones that are under the x squared and under the y squared. If the bigger one is under the x, you have a horizontal ellipse. If the bigger one is under a y, you're going to have a vertical ellipse. So this a you're going to find under the x squared. This b you're going to find under the y squared. And if the bigger number is under x, it's horizontal, and if the bigger number is under y, it's going to be vertical. B represents the minor axis, so you're going to go up and down B units to get the two covertices, and if you add them together, you get 2B is the minor axis. The last thing we have left is the focus. The focus is going to be C units away from the center. So to get your foci for a horizontal ellipse, you're going to go left and right C units. I'm going to show you guys how to get C. C squared is equal to A squared minus B squared, but we're going to get into that in the next slide. Let's go through the vertical, which is pretty much the same thing. If you go A units up and down, you get the two vertices. If you go B units left and right, you're going to get the covertices. The length of the major axis is still 2A. Length of the minor axis, still 2B. All distances you take from the center, up, down, left, and right, just like you would the circle. The foci, again, are C units away from the center, except instead of going left and right to get the focus, you're going up and down. The reason you're going up and down, the major axis is vertical. And so, as you can see, whichever way the major axis is oriented, that determines where the vertex is going to be, and it determines where the foci are going to be. Now let's take a look at our two equations. They are both basically the same equation, as I was saying before. The only difference is where a and b is. So if you look at the equation to your left, you're going to see that the a is under the x squared. And if you look at the equation to your right, you're going to see that the a is under the y squared. Now, in both of these, a is a fancy way of saying the bigger number. So whichever one has the bigger number, that's the type of ellipse it is. If x has the bigger number under it, then that is a horizontal ellipse. If y has the bigger number under it, then it is a vertical ellipse. All right. The center in both cases are HK. H is with the x, k is with the y. And for both of these, our major axis is 2a and our minor axis is 2b. The only difference is the major axis is horizontal, where a is under the x squared. The major axis is vertical if a is under the y squared. Again, a just meaning the bigger number. Vertices are on the major axis, co-vertices are on the major axis. A is the distance from center to the vertex. A is the distance from the center to the vertex. Again, only difference is when we talk about distance, if it's a horizontal ellipse, A is going to be moving left and right. If it is a vertical ellipse, A is going to be moving up and down. B is the distance from the center to the co-vertex. B is the distance from the center to the co-vertex. Now foci, this is always on the major axis, both cases. And in both cases, c squared equals a squared minus b squared. Now when you calculate c, the only difference is for horizontal ellipse, you're going to move c units left and right. For the vertical ellipse, when you calculate c, to get the foci, you're going to move c units up and down. And that's pretty much all the differences between horizontal and vertical ellipse. That's how you get every part of it. Stay tuned for examples in the next video.